Is that fine with everybody? Or some of you have clashes?
Sir, there's another class on Tuesday to Thursday from 6 to 7:30, so it will be class.
6 to 7:30, Tuesday, Thursday, both of days you have class, right?
Yes, sir.
Then you have Tuesday and Thursday, right? You have said Tuesday and Thursday, am I correct?
Yes, sir.
Okay.
Monday and
Then
Wednesday can be, if it can be done.
Monday and Wednesday,
No, sir, actually, we are having a class on Monday from 5 to 6 and also on Tuesday 5 to 6.
okay. So Tuesday and Thursday, 12 to 1:30, is that fine? Anybody has issued Tuesday and Thursday, 12 to 1:30?
So Tuesday there is a class, sir, from 6 to 7:30, sir. Which time you are saying, sir?
12 to 1:30. 12 noon to 1:30.
Sir, there's HSS for BTech from 12 a.m.
12 to
1.
12 to 1:30. Which date, sir?
Which date? So Tuesday and Thursday.
Sir, not, sir, no issue, sir.
Hello, sir.
Anybody has issued Tuesday and Thursday, 12 to 1:30?
Hello, sir.
Yeah.
Sir, multi-phase flow by Anugrah, sir, is there is a class on Wednesday, Thursday, and Friday from 12 to 1. So it will overlap on Thursday.
That means Tuesday is okay, fine?
Yes, sir.
Tuesday, 12 to 1:30 is fine with all of you. Am I correct?
No, sir, on Tuesday there's 12 to 1 is booked for HSS for BTech students.
Okay. Okay. So Tuesday is also booked. And Thursday also, I think somebody has clash, right?
Yes, sir.
How about Tuesday and Thursday, 3 to 4:30?
So, MTech students have their compulsory courses in that slot. Thermodynamics, advanced thermodynamics, 3 to 4.
3 to 4.
Tuesday, Wednesdays, and Thursday. Yeah. Sorry, it's advanced reaction engineering. I'm sorry. It's advanced reaction engineering.
On 3 to 4, right? So Monday,
Yes.
5 to 6:30. Anybody has any class?
Yes, sir. We are having like the petroleum science and technology specialization. We people are having class Monday 5 to 6.
Monday, 12 to 1:30.
Monday 12 to 1:30 is fine, sir.
All of you are fine. Monday, 12 to 1:30.
No, sir, there's again another class from 12 to 1 on Monday. Can we do it on weekends?
I can do it. I don't have any problem. But many people may raise eyebrows. You are taking classes in the weekends, right?
So from Monday to Friday, everybody is having some class in some slot.
Of course. No.
Can it be done on like Wednesday, Thursday, Friday? As I can see on the schedule, from 5 to 6:30, I think everyone is free on these 3 days, Wednesday, Thursday, Friday.
Is it so?
Actually, in these times, BTech students have minor classes, 5 to 6, Wednesday, Thursday, Friday.
Oh, okay.
Wednesday and Friday. Thursday you do not have, right?
Like 5 to 6 minor is on, like it is going on right now as well. 5 to 6, Wednesday, Thursday, Friday on 3 days.
Wednesday, Thursday, Friday, you have got the minor classes. 5 to 6. What about 6 to 7:30? Hello. Tuesday and Thursday, 6 to 7:30. Is that fine?
No, sir, it's
Sir, Tuesday, Thursday, this data science class is there, sir. Rashmi ma'am. So the
Which
same
day?
slot,
Which day?
Tuesday and Thursday,
6 to 7:30.
6 to 7:30, sir. As it's
Tuesday
an
and
elective
Thursday.
course. Yes,
Tuesday
sir.
and Thursday. Huh? So what about Wednesday and Friday?
No issue, sir. Can be done.
Wednesday and Friday is fine with me.
Wednesday and Friday, 6 to 7:30. Is that fine with all of you?
Yes, sir.
Can I freeze? So Wednesday and Friday, 6 to 7:30. Is that fine with everybody?
Yes, sir. Fine.
Yes, sir.
Yes, sir, it's fine.
Fine. Nobody has any issue. Good. So Vinod. So we freeze Wednesday and Friday,
6 to 7:30.
6 to 7:30. So if I miss class, so we will try and keep in Saturday 6 to 7:30. Okay. Weekends. If we miss classes, generally I don't like missing classes. Okay. But I mean, some commitments sometimes come when it's all inevitable. So in those sort of situations, I will take the class on Saturday, right? So let me just share the screen with you. So my screen is visible to all of you?
Yes, sir.
Yeah. So the name of the course is Fundamentals of Micro-Nano Fluidics and Microfabrication. And this will be spanning from January to April 2022. Okay, and as we have decided, the classroom will be online, and Wednesday and Friday we will meet for 1.5 hours, right? And I like this particular course to be more interactive and more the students doing rather than me, blabbering too much about the subject and all, right? It's a collective learning process that we generally follow every year. So I have given my mobile number. I have given all my contacts. You can anytime contact me. You are already in touch with the TAs. So the course objectives are given here. And the syllabus is also given here. I'm not just going to repeat them. This particular doc file I'm going to share with you immediately after the class. And the references are also given. And you will have a copy of the books available online from the TA. Okay. So just go through them. If you have any questions, you can just ask me. Slowly in the entire, you may see that, since it's a 1.5 hour of class, so roughly we will have 7 classes every month, and then about 28 to 30 classes in a semester, right? And that through that we are going to really, cover all the syllabus part that has been shown here, right? But the most interesting part of this course is that you will find that in the grading process, first of all, I am not a very strict grader. I am a very lenient grader. Many of you have done BTech courses with me, right? But then I am very strict if somebody is not attending classes, if somebody is not, copying in the exams, if somebody is doing malpractices, I am very strict. Okay. So I like to see the attendance in the class. I like to see number 2, whatever I am telling that has been followed. The lectures are attended and followed. I don't want you to read additionally much, but then when you are in the lecture, you should listen and you should follow whatever I'm saying, right? I mean, in that sense, your grade will be superb. But at the end, if you are not following that, I have seen people generally don't get good grades. So it is up to you to get a good grade. So here you will see that, a mid-sem and end-sem, I just write this mid-sem also because this time we have to conduct mid-sem also. So 10%, 10%, 20% each. One term paper will be there. So there will be 4 presentations in the term paper. Okay. So 4 presentation means, yeah.
Sir, one small happy that Sir, today you have sent one link for to attend to organize this class, sir. So now onwards, if you can just through Google Calendar, if you can set one calendar and send
Yeah, that
one
TA will
link.
do, because the date was not fixed, right?
Yes, sir.
We did not know which date the class will be there. So everything will be fixed after this class. Okay. So then I think you will be able to really follow that, right? So Vinod, you set a Google Calendar so that everybody knows which date, which class, and link and all. You set it in the beginning itself, right?
Yes, yes, sir.
Yeah. So we have 50% of the term paper, which will composed of 4 presentations. Okay, this is essentially your main exam. Whereas mid-sem and end-sem will be some very open-ended problems I'll be floating for all of you to appear for the exam. So in the presentations, I just show you a few things. What I expect in a presentation is this, that in the term paper, so what we will do, we will try and create. So this is the typical, like what exactly we are expecting in the term paper, right? So we will have 4 presentations. What are the 4 presentations? Suppose the first week of February, right? Typically, we will try to hold this on the number 1 point is that we will try to hold this in the weekends. Okay, during the weekends. And this will consist of what? 4 presentations. So typically, I have seen about 30 students are there. So we will have about 10 batches. Right? Each batch will consist of, say, 3 students. Okay. Now, what I will do, this will be done during the weekend, say the first week of February. Okay, then first week of March. Okay, then first week of April. And then finally, maybe the last week of April. Okay, so there'll be 4 such. Okay, so these 4 will have, each will have 15% weightage. So altogether, you will have 60% weightage, right? Now in that, what I will do, I'm going to make sure that each one of you have a very advanced topic. Okay, that I'm going to share with you. So each group will have an advanced topic. Each of the group will have an advanced topic. Right? So 10 groups will have, so essentially what am I eyeing here? There will be 10 such topics. Okay. Now in these 10 topics, what you have to do, you have to divide your 4 presentation. The first one will be what? The first one will be a kind of, introduction. Okay. Second one will be on computation. Third one will be on experimental. And fourth one will be on the combined. What do I mean by that? In the first one, you are expected to give me the introduction. I mean, you have to go through the literature. You have to find out. You have to find out the details of the literature. Typically, each of these presentations should be spanning. The presentation should be spanning 10 minutes. Each one of you should present for 10 minutes. That means 10 slides. Okay, so 1 is the initial slide, and then and 10th is the thank you slide, right? But in between, you will get an opportunity to present 8 slides. In those 8 slides, you will break down into different parts based on the topic and subject in each case. So in introduction, you are going to really talk about, say, in these 8 slides, you are going to talk about, like, say, suppose the background, okay, the fundamentals, okay, maybe this may be 2 slides, fundamentals, this is 2 slides, okay, some breakthroughs, 2 slides, and then maybe some applications, 2 slides. Right. So this will be your intro. Now, after the intro, when you go to the computation, so from intro, these 10 slides, you are going to squeeze intro into 2 slides, right? And then rest of the 6 slides, you are going to pick up a computational problem related to the topic, and then make a 6-slide presentation. In that, you can go for, like, model, solution methodology, and some important results. Similarly, for experiments, now you are going to summarize intro with 2 slides, computational with 2 slides, and then experimental for another 4 slides. And then when you go for combined, in the combined you come up with a new idea. After you introduce all the 3 what you have done in the entire semester, you present 2 slides with a new idea. Okay. Any questions in this? You have any question in this?
Sir, can you show us a sample penetration so that we can get a better idea?
Yes. So, say suppose I was going through. These are the 10-11 topics that I have shortlisted. So let me just show which one. Say DNA nano device. Okay. It's a very latest one. This is December 2021. This has come up as a news in Nature Nanotechnology. Okay, it's one of the most prestigious journals, right? So it says that a DNA nano device boosts tumor immunity. This is the topic. Okay, so your topic is DNA nano device. So what is a DNA nano device? So how is it done? You see that there is a tumor cell. Okay, there is a T cell. This is inactive T cell, and say suppose this is the M2 tumor associated with some macrophage. Okay, and then you put a kind of nano device. This nano device helps these two in binding. This is the essential concept. It is schematically shown. Right. Now, what this nano device does, it goes inside this particular macrophage. It produces some ligands, which helps the binding between the T cell and this cell. Right. Now, since this DNA nano device, they have used for a specific purpose, right? In this particular case. So you have to. What is the introduction? When I share this paper with you, you will see if you go to references. This is called cross-referencing. So you have at least 13 references here. So your first job will be to download all these references. So essentially, you may see that there are a lot of latest papers. These are all top journals of this globe. Okay, and from there you will get a lot of information related to what is first DNA, what is first nano device. Okay, how these DNA nano devices are made, what are the typical histories. So in the introduction presentation, you have to just tell me, what is a DNA nano device? What is the science behind a DNA nano? But first, what is a DNA? First, what is a nano device? Okay, then how come a DNA becomes nano device? How are they synthesized typically? Right? What was the first DNA nano device that was prepared? And then what are the different applications associated with that? So you have typically about 14 to 15 papers along inside your kitty, which can first you get a brief introduction, brief idea about what's going on. That will be your content for the first presentation. So essentially in a month, say starting from today, 7th of January until say suppose 1st of February, you are reading about 13 to 14 papers in your room, which are the ones you can see here. The papers are. My slide, this thing is visible to all of you, right? The screen is visible to all of you, right? So you are essentially reading from 2011 to 2021, all the recent papers. And from there, you are summarizing a story 10 slides on our topic called DNA nano device. Okay. Now, second is in the computational one, you have to say that how can you computationally model this? Say, suppose if I tell you to computationally model a DNA nano device, how do you do that? So first, how a DNA is computationally modeled, then a nano device is computationally modeled, and how do you join them in order to come up with a computational concept? I'm pretty much sure in these papers you will find a lot of hints on that. Third is what is an experimental process? Suppose this is itself is a kind of very nice biotechnological applications, healthcare application. So you can really focus on this application. Say suppose this looks like a schema, right? But then how do I really, if I am given the chemicals, if I am into a kind of like, a system where consumables, chemicals, everything is available, how do I make sure that this happens in reality? Right? So that is your experimental part. Now, once you are done with these three presentations, then the final presentation will be whatever is available around you. I think by then you will be in the campus. By March end, you will be in the campus. And then, you just mix bits and pieces here and there, collect from laboratory some of the things. I will also help you in getting some chemicals. So take those chemicals and then, come up with a very small prototype. The first engineering device of your life. This is what I say in every introductory class of CL625, that in April 2022 or April the year N, I have been telling for last 3-4 years that you will have your first own engineering device made by you using this concept in the domain of nano, right? You are having your first own device. Could I answer your question? Who asked the question?
Yes, sir. It's fine now.
Is it clear?
Yes, sir.
Right. Similarly, you will find that there is another paper in this repository. All these papers will be shared with all of you. Right. So this is called a three-dimensional transistor array. So most of the transistors these days are 2D transistors, and you know that since they are 2D, the number is becoming limited, and then we are reaching a kind of Moore's law in terms of the saturation of the memory. Correct. Now, three-dimensional transistor arrays are prepared for what? For what purpose? For intra and intercellular recording. So these transistors are used. This article is, you may find that the date is very near. I think it will be in 2021 only, December 2021. Somewhere it is written. So just check it. So this particular transistor is used for, say, suppose these cells are there, right? So between the cells, what happens? And inside the cell, what happens? You get both the information using this sort of transistors, right? So essentially, you can really follow the activities inside the cell using this sort of transistors, right? So you can see that this probe is getting into the cell, and say suppose if this is a cancerous cell, so this is a HeLa cell, okay? Say suppose this is a kind of neonatal mouse cell, this is an adult mouse cell. So in these cells, if you put the probe, what is happening? The probe is able to really detect what's going on inside the cell. The idea behind the whole process is that, to give you the state of art, what can I say? State of art understanding or state of art knowledge related to the science. You have to really understand where science has gone today as compared to the studies that you have done up to this point, right? So this is a typical fluorescence microscopy where the cells, these HeLa cells are flooded on this FET array, and they are continuously getting the signals from the cell, right? And that's the reason why this is in this particular. See, you can see the different types of behaviors of the cells that are being figured out, and that's why this is in this particular top class journal it is being published, right? So the problem with our education, so this is in October 27th October, is the November 2021 this particular paper was accepted. And if you go through the whole thing, you will find out these are all possible in the places like IITs, ISC in India, all top class universities and colleges. It is possible to do this sort of research, this sort of fabrication, this sort of characterization. It is possible, every place that we belong. Only thing that we need to really understand what is the level. When I show this, that means it has already happened. You have to understand this point. When I'm showing this example, this has already happened. That means this is already history. You cannot really invent this process once again. Your level of understanding, your contribution to science will only become novel when you can come up with something extraordinarily new, something like this. I'm pretty much sure before today, none of you have heard about this thing. Okay, and today only for the first time you're observing this thing. And in Nature Nanotechnology, only those sort of things are published, which are for the first time the whole world sees. The idea has to be absolutely novel. And here it is given how is it to be done. All the steps are given how they have done, so that this is reproducible any part of the globe. This is a typical computational model. You can see that they generally this is a computational model that is done in order to know what is the electron distribution, that current distribution. So some equations are solved. So typically you will get, while going through these papers, you will get a very nice idea about what is the standard of science, what is the standard of technology across the globe. And from there, you have to really gear up and you have to pull yourself up in order to really come up with something which is very state of art. That is the whole purpose of this course, that, to make you read about 20-30 papers, which are 2021, 2022, at the level of 2021, 2022. And then, your brain is trained with the latest ideas and come up with research prototypes, which are very, very relevant to 2022. Right. So in this paper also, you may see there are a lot of cross-referencing can be done with different types of classical to fundamental to latest papers. So the whole idea is that, say, suppose if somebody is, if I say that 3D transistor arrays. So what you do a nice literature in terms of introduction. You do then you go look for a computational model. You look for an experimental one and then come up with a new idea. So these are the 4 steps of your term paper. So finally, when you give me the full package. Okay, and 10 groups making 10-minute presentation means, we will spend 1.5 class, during the weekends, where all of you will be presenting. And in that, I also mark, you also mark. My mark will be having 50% weightage. All of you will mark, apart from yourself, other groups, and that will carry 50% marks. So there will be a kind of uniformity associated with the presentations in terms of the way I'm marking and the way you are marking. And only thing that is there is that 3 of you in a group will get the same mark. That is the only limitation. Why I do that? Because I feel that all of you should be learning a teamwork. So the idea of this particular term paper is manifold. Number 1, you will learn how to present. Number 2, you will reach out to 2 of your friends in order to prepare the presentations. Okay, so there will be hand holding sometime, there will be mentorship, there will be leading. Okay, all these activities will be happening simultaneously around you, right? So you first the first thing is that you are going to lead. Second thing is that you are going to learn how to present. Third thing is you are going to form a team, and you have to do a kind of teamwork. Fourth objective is you are going to be technically make yourself technically competent with the latest technologies and science. And fifth is you have to come up with some novel ideas, very novel ideas which are state of art and new. Okay. Similarly, you will find this is a battery. I have given another problem which is on low temperature sodium metal battery. This is a very new concept. Okay. So I have just given the name as a battery. very interesting things are there. This is a light fueled nano ratchet. Okay, so you can see you will immediately get interested when you see the entire ratchet. Okay, so this is the typical architecture of the device, right? And if you put light, you will see that it will start behaving. It will start giving some of this signals and noises, right? So then you have meta vehicles and meta surfaces. So meta means what your physics you understand, right? What you understand is physics. Related to physical sciences, what you understand is physics. What you don't understand, that is called metaphysics. So meta surfaces, microscopic meta vehicles. That means vehicles that are not understood. Powered and steered by embedded optical meta surfaces. Meta surfaces means surfaces, those which are again not understood, right? So you can see that this is a typical meta vehicle with meta surfaces. So you can look at different types of movement, motions, and all these things associated. So then there is a nano supercapacitor. So you can see two-dimensional quantum sheet films with sub 1.2 nanometer channels for ultra high rate electrochemical capacitance. So this is a kind of supercapacitor, which is a nanoscale supercapacitor. Then there is photonic quantum technologies. A set of quantum technologies are given as term paper this time, right? So this is a quantum dot based photon emitter, right? Right now there are two very important technologies that are becoming very important globally. One is the photon emitter, electron emitter, all these things, because these are the main sources of characterization. And second is the single electron detector, single photon detector, right? It is not multiple photon detector, it is a single photon detector. Right? Can I detect a single photon, right? So can I really emit a single photon? Can I create a technology which can emit a single photon, right? So you can see this is a quantum dot based deterministic photon emitter. Then this is a plasmonic water splitting. Plasmons are what? It's basically like, on the metal surface, if you have a metal dielectric interface, if you put light, what happens? The phenomena called surface plasmon resonance that happens, right? Now with that, what you can do, you can split water and you can produce hydrogen. So hydrogen energy can be produced, right? Then you have got this another technology that is becoming very popular. This is called the quantum internet. I just show you the picture. So this is the picture of the quantum internet that is coming to the forefront over a period of time, right? In 1995, how many of you have heard recent Elon Musk's interview where he talked about Bill Gates? Have you heard it? Any one of you? Yes, no? Somebody should say yes. Have you heard? Any one of you have heard? Anybody? It's deafening silence. Anybody is there or not? Hello? Am I audible?
Yes, sir, you are audible.
Oh, it looks like my screen is frozen. Is it, sir?
Hello, guys. I'm one of the TAs. Please hold for some times. It happens sometimes with such systems. So, sir, we'll get back to you soon.
So I was audible, right? Only video was not there. Am I correct? My video was frozen, right? I was audible. I was talking up to this quantum internet.
Yes, so even your video was visible. So
okay, some issue. I saw my there's a bug in this Microsoft team. While sharing, it happens. Yeah, it's visible now to all of you, right?
yes, sir.
Yeah, so any one of you have heard about this term called, I mean, this interview by Elon Musk very recently, where he spoke about Bill Gates? Yes, no?
No, sir.
No? So just hear the interview where he was mentioning about, there is an old interview by Bill Gates, I think in 1996. Where he told that how the entire mode of communication will be emails, and how the entire mode of communications will be some devices, some small devices, handheld devices, just like a mobile phone. And he was speaking about early 90s, where there was absolutely no clue of the mobile phone or like tabs and all these things. Just listen to the that vision map that he was playing. People were laughing. The interviewer who was asking questions, he was laughing that this guy is crazy and have absolutely no. He's saying something which is perhaps impossible, right? But 20 years down the line, you may see that that's the reality. So this quantum internet is a concept which is coming in a very, very fast manner. That how exactly the world will get integrated in terms of the use of different quantum technologies are going to really integrate the whole ecosystem of internet. So this is the next generation that is coming, right? And nanotechnology is perhaps the here the nanotechnology will be the host in all these quantum based devices or technologies. So it's high time that all of you start putting effort in terms of understanding these things. So that's why I have floated quite a few topics on this quantum internet. The other one is the quantum tomography. Okay, tomography you all know, right? What is tomography? Tomography means, say, suppose you are doing this CT scan, right? So what is this T stands for? The T is the tomography, right? So you put a radioactive particle and then you keep tracing that particle, which is very weakly radioactive, and then tracing that particle, through which the channel and all it is going, right? So similarly, quantum tomography is another very, very important part that is coming from the 3-qubit state in silicon, right? So qubit means the quantum bits, right? So bits are getting into the domain of the qubits, right? So you just look at how exactly they are fabricated, and from there how the concepts are built up. So just go through that. These are all exploratory, and nothing is written in these papers which you will not be able to understand or you do not have a background for. Okay, only thing that you need to do is do a little bit of study and understand this is a little bit ahead of, a little bit away from where is the finishing line that you have right now placed by yourself. Okay, in knowledge domain in general, we put our limit in the way we read things, the way we explore things, the way we try to visualize what it can be. So what I have done in all these topics, what I have done, I have put all these milestones a little away from that. And I'm pretty much sure whatever papers I have shown you today, none of them you have seen in your whole life. And that was the essential idea, that first half an hour, first 45 minutes, what I'll be talking about, that will be absolutely away from what you know, right? So that you get enough motivation to really explore and study. So this is another project which will be on silicon spin qubits. So qubits, you will find that this will be the one where which will be the next generation of the quantum computational and technologies related to that. How semiconductor devices, how the microfabricated devices, how microfluidic devices, how nanofluidic devices, how the memories, how exactly the transistors, they are going to be revolutionized using these concepts, right? So you will have a very decent write-up in all these papers, because generally those who are writing these papers, they are the ones who are the masters, who are the top-notch experts of these areas. And you are reading their writing means you are basically getting yourself acquainted with the knowledge that is relevant to 7 January 2022. Idea here is that you first read them multiple times, understand what has been written, discuss among yourselves. You have a team of 3, discuss among yourselves. If not, discuss with me. If not, look at the literature, look at the contents, internet contents. From there, try and understand, and then come up with step-by-step process, so that you have some control over these topics at the end. Right. This also helps you in terms of different, say, preparing a statement of purpose during your PhD, right? For job, when you are preparing, when you are looking in the job interviews, when you talk about something, your material will be ready. So in multiple ways, if you just put this effort, what happens in multiple ways, it is going to benefit in future. Okay. So overall, I hope I could give you an idea about all the projects. So Vinod, I will mail you the entire folder, right? And I think we have the list of the students here. So Vinod, I will assign Vinod to prepare the groups. He will prepare very, very neutrally without getting into anybody any bias. So he will prepare the groups for you, 1, 2, 3, 4, and say by weekend you will have the groups and the assigned projects, right? And then the job starts. So you slowly start working on your 10 slides for the February presentation while I progress in the classroom lectures, right? And in general, you will find I find it very, what can I say? I find it very happy if you can really take out the class teachings into these presentations. So some way, all these term papers also should be connected to the course. You should try and connect. These are all at the periphery of the course that we are going to study for next 2-3 years and 2-3 months. And then, you connect these stories to whatever you are studying in the class. So I feel very happy if you connect it in some way or other on your own way. I mean, I don't want to really, I will not also mind if you don't connect, but if you can connect, then that will be very interesting to see how you connect to the course and all. Okay. Any questions you have up to this point? Yeah, any question you have? Any question related to the term paper?
Hello.
Yeah.
Sir, the students list, has it been updated? So, because I couldn't see my name over there.
Are it in the academic section?
No, sir. This Excel file that you.
No. This I have taken. This I have taken before, even before. Yeah. I will put your name.
Okay.
These 5 people, I think in the academic web page, these 5 people do not have the name.
Sir, my name is also not showing.
What is your name?
Sir, Anushka.
Anushka. Okay. Yeah.
Sir, sleeve is also not there.
What is your name?
Tejas Rai.
You also mailed today morning, right?
Yes, sir.
Yeah, all of you log in. So then what happens? It becomes easier for. Anyway, I have put down your names. So TA will be in touch. Vinod and Prathu will be in touch with you. You update all the details, your roll number, mobile number, and I think email is already there with him. Okay, so he will make the group, right? And meanwhile, you complete your registration process in the academic portal, right? Anybody's name missing? Anybody's name missing?
Hello, sir.
Yeah.
Sir, actually, I have registered for the course and I did not drop it, but here it is showing means against my name it is dropped.
Yeah. So you wrote
also.
You wrote an email, right?
Yes, sir. Actually, I wrote in the morning.
So right now everybody is under lockdown, so you have to wait until this mess is over, right? So
yes,
I think that when they come back, they'll do it. Don't worry about all these things. Anyway, you are attending classes, right?
Yes, sir.
They will do it. Keep following up with them.
Okay, sir. Okay.
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 Yeah. Anybody else has any issue? No. So let me just quickly revise the whole thing about the course. January to April, Wednesday, Friday, 6 to 7:30. We are going to have classes. We will have 4 presentations. Okay, each will be 50% means 12.5% weightage. Okay. One introduction, one computational, one experimental, and one is your own idea coming out of the whole process. But as you progress, you carry forward the previous presentations. That is the whole purpose of the term paper, which is the main weightage. Quiz 30%, 3 quizzes. This we drop, right? So let us keep this to be 60%. This was last year because midsem and insem 40%. Okay, 20% each. Anyway, I'm evaluating with the presentation, right? So this is fine with all of you. 20% each, midsem 20%, and sem 20%. Right? Maybe what we do, this we keep as 50%. I keep some in the attendance because some of you don't join. I don't keep this. Right? So 10% for online attendance, midsem and insem 20%, and term paper is. So midsem we keep as 15% each. 40, we keep this as 30. So each presentation is about 15% weightage. Frozen. Right? Right, Vinod? So I send this thing to everybody then. Okay? Right. So then let us start the lecture part. Okay? So can anybody tell me what are your expectations? Maybe all of you chip in with a few words. What are your expectations from this course? Why are you doing this course? One by one, quickly. Amrita.
Yes.
Hello, sir.
Yeah, Amrita.
Yes. Good evening, everyone. Like since sir, you have said right now that in this field of nanotechnology, that is the field that will be governing us in the recent era, that is the upcoming era. So that is will be the field that will be showing us.
Any specific agenda that you are coming up with?
Not yet, sir, but I will be like specifying whether I would be able to find out, since my project is also based on related to some like medical applications of it or something. developing something related to anything that is not yet found out.
Okay, good. Anushka?
Yes, sir. I was motivated to take this subject because so I actually wanted to know how, like, if I have read somewhere that this quantum effects come into play when at nanoscales. So, like, how that theory can help us in knowing about those nano-sized particles or analysis for knowing this. That's why I thought to take this subject.
Yeah, thank you. Aritra?
So actually, the motivation was mainly my MTP, sir. It was based on the unit operations in the microfluids. So for this, I will be able to know the various the operations that are going to be in this very small scale. So which we actually study on the larger scale previously, but for this time we can also I can get a glimpse of or a small idea about this microfluid operation.
Yes, Govinda.
Good evening, sir.
Good evening. Yeah.
Sir, with respect to quantum effect, how does microfabrication works in the nanoscale, sir? That basically motivates me, sir.
Thank you. Karan?
Yes, sir. So I was particularly interested in pursuing research in nanoscience and nanotechnology, and I heard from the seniors that this course is very good, and that there is a part about the analysis of nanoparticles which is covered later on. So I thought that would be helpful if I want to pursue nanotechnology later.
Thanks, Karan. Kumar, Kartikeya Kumar Singh.
Yes, good evening, sir.
Yeah, good evening.
Yes, sir. Yes, sir. Actually, sir, this subject, sir, deals with particles at micro and nano level. So, sir, I want to learn something about this subject, and I also heard from a senior that this subject is also interesting. That's why I registered for this course.
Yeah, Anubhav.
Hi, sir. Sir, I remember in my probably in the second year, you had shown me one device which had some fluid and some nanoparticles inside, and that was some sort of a pump. So that got me intrigued, and I asked a few seniors. They told the course is really good, so I thought I'll take this.
Great. Uday?
Yes, sir. So my motivation to take up this course is I mean, I've been always curious how what can we say, how microelectronic devices can like blend with the actual biological world, and how certain shortcomings which are present in the nature can be overcome using micro nano technology. So this curiosity has driven me towards this course, and I'm looking forward to learning a lot from it.
Yeah, thank you. Muhammad?
Hello, sir.
Yeah, hello. Yeah.
Yeah, sir. So the motivation was actually I have gone through a couple of papers regarding carbon dots, and I really want to combine the microfluidics and the flow chemistry to reduce the reaction time to produce the carbon dots. So first motivation is that, and second motivation is that after reading through the Bretherton's classical problem paper, I just wanted to know how the surface effects dominate over the gravitational effects at the low capillaries, the small capillaries.
Yes.
So these two were the motivations regarding to take this course.
Great. Musadik?
Hello, sir.
Hello.
Yes, sir. Sir, actually, I am changing my research area from energy to this micro and nanofluidics. So, according to me, I thought that this course will be the means ideal for me to start with from in the transition stage, so that I can get knowledge about this, more knowledge about micro and nano. So this is the main motivation of taking this course.
Thank you. Nilima?
Yes, my motivation is when we are in second year, you have given one presentation about nanotechnology. about your project, and that time I am very much fascinated about this course and nanotechnology. That's why I have taken this course, and I have also heard that this is very good course, and I'm really looking forward to learn something new about the technology.
Yeah, thank you. Niru.
Good evening, sir.
Good evening.
I took this subject for a deeper overview of nanotechnology for various purposes.
Great, thank you. Rajan.
Good evening, sir.
Good evening.
Sir, my motivation for taking this course is like practical approach towards the subject, and apart from that, my guide told to take this subject, micro and nanofluidics. My research work will be based on this. That's why I'm taking this course.
Thank you, Rajan. Ram Avtar. Ram Avtar, are you there? Sharma? Hello?
Yes, sir. The motivation. Yes, sir.
Yeah, please go ahead.
Yeah. So the motivation behind taking this course is that, as I have read in some paper, that we are reaching the limitation towards the Moore's law, and what happened after that, the qubits will come into place. So I just want to know some or gain some deeper knowledge regarding this.
Thank you. Shivangi?
Good evening, sir.
Good evening. Yeah, please go ahead.
Yes, sir. My project work is based on the manufacturing of microfluidic device, channeling and fabrication. So I took this subject.
Okay.
Thank you.
Thank you. Shubham?
Yes, sir. Good evening, sir. So in second year, I took I had a course on fluid dynamics. I really liked that course, and then I saw the course content. It seemed an extension of that course. So I took this course to learn more about it.
Yeah. Thank you, Shubham. Srijita?
Thank you, sir.
Good evening, sir. I have read somewhere about the relation between quantum particles and these nanoparticles, and it is actually interesting. And also, it's new age applications. Actually, it sounds interesting, and also my MTP project will be on related to this. So I took this up.
Thank you. Suraj? Suraj, are you there? Sushil?
Yes, sir. Good evening, everyone. So actually, I really don't. I know little about the micro nanofluids. So my motive is to just to learn something new, and so I would like to improve my knowledge in this field. So yeah, that's why.
Thank you. Thank you, Sushil. Subranil?
Good evening, sir. Sir, actually, my motivation is to that, sir. I have studied the process integration process integration subject in the previous semester, where I got acquainted with the micro reactors and micro channels. So I just want to, I'm just keen to know about this, about the nano application into this particular field that can come to my, that can be fruitful for my research. Sir.
Yeah, thank you. Thank you so much. Swarupa?
Yes, sir. Good evening, everyone. Sir, I'm really interested in nanotechnology, which has many applications in industrial or day-to-day life. And you have given such a good projects. So I'm looking forward to learn more things through projects. Thank you.
Thank you, Swarupa. Tejas?
Yes, sir. My motivation is I really want to know what happens when we go down to nano size and what sort of miracles we can do if we fully understand nanotechnology. Also, sir, my major project topic is nano patterning of polymer film. So the subject will surely help me in my major project. Thank you, sir.
Yeah, thank you, Tejas. Varun? Varun, are you there?
Yes, sir. So, as for my motivation for learning this course, it is somewhat a very subdued field, mainly inkjet printing. I have heard about inkjet printers, and the application of microfluidics there was something that interested me because I always wondered how such, how high resolution images could be produced using microfluidics. So I wanted to learn more about that through this course.
Yeah, great. First, this introduction was necessary for me to just to see, like, who are sitting on the other side of the table. Okay, so thank you for all your inputs. Now, as we start progressing on the field of micro nanotechnology, I will try. See, it is also very important for me to know, I mean, what are you expecting from me in terms of the course? So I will try and incorporate some of the things that you people have in terms of your MTP and all other targets that you want to do. But then, I mean, of course, it will be whatever you have said, it will be very different from what you expect, right? So let me just show you an example. Okay. Can anybody tell me what is this in the middle? Any idea? What is this?
Channel.
Hair.
So it's a hair strand.
Yes.
Strand
So
of
what is the diameter of the hair? Say suppose your hair, what is the typical diameter of hair?
Except 500 to 1000 nanometers.
500 nanometer, you have a very healthy hair. 500 nanometer, you say? Huh? 500 nanometer, about 0.5 micron. You have a very poor hair. It is not at all good. What is the typical diameter of hair? It is written, no? What is this?
0.07 millimeter.
Nanometer.
But then,
7 nanometer.
7 nanometer? 0.07 millimeter means 7 nanometer?
Oh, sorry.
So how many millimeters leads to micrometer? So first we have to understand the dimension. Am I correct? Am I correct or wrong?
Yes, sir.
So even if you do something else, you see, everything should not be high flying. And I talk about quantum, this, that, always, right? But then science is always, it's a bottom up process. You have to take step by step. I'm asking a very simple question. What is micro? What is nano? So how much micro leads to millimeter? Any idea? Anybody has 1000 microns?
10 to the power minus 3.
10 to the power minus 3 what? Unit? Millimeter, right? Is equal to 1 micro. Am I correct?
Yes.
So 10 to the minus 6 meter is 1 micro. That means 10 to the minus 3 millimeter is 10 to the minus 3 millimeters is 1 micro. So what is the diameter of
1
hair?
micron.
What is the diameter of hair? Why there is so much of silence?
Sir, it's 70,000 nanometer.
What? Very good. Very good. In terms of micrometer?
70
micrometer.
70 micrometer.
70 micrometer, right? देखो इतना छोटा सा calculation कितना time लग गया, right? So this entire thing that is there on top of your head is what? Is nothing but micro technology. Okay, it's all microfabrication. These are called fibrillar surfaces. Scientifically, these are called fibrillar surfaces. That means a surface is full of fibers. This is one type of fibrillar surface. This is one type of fibrillar surface. What is the purpose of this fibrillar surface? It's like, say suppose if there is water, no, it is not going to get into the system. It is just going to, like, water, any type of water, it leads to water repellency, right? So say suppose if you have a cube whose one of the side is 1 millimeter, what will be the volume of the cube? What will be the volume of the cube if you have the sides that are 1 millimeter?
1 nanometer, sir.
Size, volume.
10 to the power minus 9 meter cube.
Volume will be
10 to the power minus 9 meter.
1 millimeter, 10 to the minus 9. Very good. So you can see here, I have given some of these dimensions. Say 1 liter is about 1 decimeter cube, right? So 1 microliter is what? 1 microliter is, say suppose millimeter, no? So since this is decimeter cube, right? So you will see 1 millimeter cube will lead to what? See, this is 10 to the power minus 9, correct? See, this is 10 to the minus 3 meter. That means what? 10 to the power minus 2 decimeter. Now, if you multiply 10 to the minus 2, 10 to the minus 2, 10 to the minus 2, correct? So then what happens? Then you get what? If you multiply 10 to the minus 2 in this direction, 10 to the minus 2 in this direction, and then what will be the third direction? 10 to the minus 2 in this direction. Then what is the volume that you get?
10 to the power minus 6.
Microliter. Because liter is decimeter cube. Correct? So 1 millimeter cube leads to 1 microliter. 100 micrometer cube leads to 1 nanoliter. 10 micrometer cubes leads to 1 picoliter. And 1 micrometer cube leads to 1 femtoliter. So what am I doing? From here to here, as I am going down, what is this particular thing is called? This particular thing, this particular process, when I'm going down in a dimension like this, when I'm going down from here to here, this particular process is called what? This is called the miniaturization. How does it appear? So a cubic box is 1 microliter is a cubic box of 1 millimeter. This is 1 nanoliter, right? What has happened? So you can see that 10 units, you have just shortened the whole thing by 10 units. Then this becomes 1 picoliter. Then even smaller, that becomes 1 femtoliter. So as you reduce the dimension, what happens? In terms of volume, it goes 3 times lesser. And this whole process is called the miniaturization process. So in micro-nano, what you are essentially attempting, any field related to micro-nano, what you are essentially attempting, you are attempting a process called miniaturization, right? Now this miniaturization, the advantages associated with miniaturization that we are going to study in the entire course, the different aspects of the different advantages that are associated with this. Okay. Yeah. So what are the typical examples that you have? Say with coronavirus around us, I don't need to really tell you what is happening with what is the size of a coronavirus? By the way, what is the size of a coronavirus? Anybody has any idea? Hello, nobody has idea about coronavirus. What is the diameter of a coronavirus?
Sir, it's 50 to 140 nanometer.
Right, so it's a nanoparticle, correct? And what is the typical diameter of your lung You know these alveoli? Any idea? I have written here. Main bronchioles are 10 millimeter. Finest bronchioles are about 0.4 millimeter. Alveoli about 0.2 millimeter. So this is the trachea. Then it gets into branches into parts. Then bronchus, then bronchioles, and then finally at the top you will have alveoli, right? This is essentially a kind of a hierarchical structure. These are also called the fractal structures. So it's a beautiful example of miniaturization of the diameter. The diameter of the trachea is here, and as it goes down, it becomes smaller and smaller in terms of channels. So in alveoli, I have got vessels which are of the order of 200 micrometer. Bronchial tubes are about 400 micrometer, right? So when you are inhaling these coronaviruses, what is happening? These coronaviruses are entering through these nostrils, these bronchus and bronchiole, and it is going into these branches into this, right? And then these are all coated with a very thin film of the mucus, and this coronavirus is interacting with this mucus in order to create what? In order to create a jelly-like substance, in order to create a kind of polymeric substance, which is leading to what? The thickening of the mucus, and that is leading to what? That is leading to the severe distress called, one of the distresses is called that ARDS, right? That is called acute respiratory distress syndrome, and the other is called the COPD, that is chronic obstructive pulmonary diseases. So you are getting an array of these diseases due to the coronavirus infection in these branches of this lung. And this is nothing but the excellence of nanotechnology, such a robust system like a human body, that has been flowed with the help of just multiplication of this particle, the capacity of fast multiplication of this particle, leading to the congestion of these lungs, which is the major way of choking the respiration and killing millions and billions of human beings, right? So you can see how effective this nanotechnology can be, and what is the solution human being is creating. You can see that you are generating aerosols. These are essentially those pumps that are used to solve the used to really destroy these these COPD related congestions, where you use some antibiotics, you use some of the chemicals, which is going to either expand the lung linings, or it is going to kill the bacteria or the viruses before they really multiply, in order to make sure that this lung aerial, the roots in the lung airways are cleaned, right? So this is one very beautiful example of microfluidic applications. Okay, I'll come back to this in the next class. So in a process like this, what are the things that you need to know really? Right, in a process of miniaturization, in a process of say you are dealing with a lot of things since your childhood, like physics, chemistry, math, right? And then you have done science, and then now you are doing engineering, right? You're dealing with a lot of things. What are the typical things that you require in order to really be specific, and then understand the science fully, and then understand the applications associated with that, right? So you just need to have a very comprehensive knowledge about the materials. Then you need to know how these materials are synthesized. Okay, then you need to know how these synthesized materials are fabricated in different ways. Once you are through with all these three things, you need to characterize. Say, suppose you have decided a material sodium. So from the salt, you have synthesized sodium, right? And then you created a bead of a sodium in terms of fabrication. But then you need to know whether that is sodium or not, right? So for that, you need to do characterization. If you combine all these four, you will have a very good knowledge about the material that you have synthesized, fabricated, and characterized. Then you are ready for thinking about what are the different applications possible. Okay, then once it is applied, how the commerce associated with that, how do you recycle associated with that. But then as a scientist, you have got two major important as a scientist, as an engineer, you have got two major important aspects associated with the whole process. Is that first you have to be responsible, and then you have to really enjoy this process again and again, so that it becomes a part of your life, right? And over this particular course, we'll try and see how exactly we follow these steps one by one in order to make sure that we understand a scientific process conceptually, and at the same time we have enough methods, enough knowledge in order to really come up with applications associated with that process. So it's a very simple example I'm telling you. This is a kind of graphene sheet, right? Anybody has any idea what is a graphene sheet? Anybody has any idea what is a graphene sheet? Why there is silence? You do not know?
Graphene sheet are two-dimensional sheets.
Yes, of what?
Of carbon, sir.
It's an
Carbon
allotrope
nano.
of allotrope of
Yes.
carbon, right?
Allotrope of carbon, yes, sir.
So what is the hybridization?
Sir, it is sp2 hybridized, sir.
sp2 hybridized, right? So it's essentially you have a sheet of sp2 hybridized carbon, right?
Sir.
Now, whether this is, my question is that whether this is, whether diamond is stronger or graphene is stronger?
Sir, graphene is stronger than diamond.
Why? Why? Any idea why graphene is stronger than diamond?
Actually,
very simple question I'm asking. I ask in a different way. Say graphite and diamond, which one is stronger?
Diamond.
Diamond. But then graphene and diamond?
Graphene.
Why?
So because the different layers of sheet have kind of a
strong intermolecular bonding.
Attraction between.
Intermolecular bonding makes it stronger.
Yes.
So two questions I'm asking. Okay. See, this is I'm going to do in the entire course for all of you. Please remember, I will ask some open-ended questions. Okay. So next class is Wednesday 6. Correct. So before 6 p.m. next Wednesday, you are going to write on a piece of paper the answer of those questions, and you are going to submit to the TA. Right? Those who are submitting all the questions and answers, if you have some problem while grading, if you have a few marks, you want to get the next grade, I'll consider them only. If you have any request in terms of revision of your copies and all marks, I will be doing that only when you submit throughout the semester these answers to the questions. Is that fair?
Yes, sir.
So first question I'm asking, these are the two questions that you have to write on a piece of paper. Don't write too many things. Be very specific, 4 lines each, and finish it just after the class in 10-15 minutes, because otherwise you will forget. First question is, why graphene is stronger than diamond? I want a scientific answer. Okay. Number 2 is, graphene is conducting and diamond is non-conducting. Why? Is it clear? Conducting in the form of the electrical conductivity. Okay. I just give you the hint. If it is sp2 hybridized, that means each 2 carbon has a sigma bond and a pi bond shared, right? So that is the reason why the single sheet. See, when it is graphite, the sheets are loosely bound. They are sleeping against each other. That's the reason why you can use it for writing, because you are depositing layer by layer on the surface. Right? But when you really come up to a single layer, since this is sp2 hybridized, the bonds are much stronger than diamond. So now if you roll them, if I roll a graphene, this type of tubes, what is the name of them? If I roll them like, yeah, these are called carbon nanotubes, right? Now, you can see that this is a kind of next generation brick that has been thought of. It is all made of carbon. Right now, anybody has any idea how the bricks are made? How the house bricks are made? Any idea? What are the material of construction there? What are the materials of construction there? Bricks. Any idea?
Asking about general bricks, sir.
Yeah.
Sir, they are made by soil, sir, by burning the soil, sir.
So what is the material of construction?
Soil.
What is the material? You are a chemist, right, Govindo?
Sir.
Silica.
Yes, silicon.
Yes.
Calcium,
silicon,
aluminium,
sir.
silicate, right?
Silicon.
Calcium,
Yes,
aluminium, and silicon. 3 oxides are there, right? So it's a ceramic material, right? So ashes are also used. Fly ashes are also used. These days, you are getting fly ash bricks, right? Again, you will find like, all these inorganic metals, metal oxide. That you get into these bricks. But the next generation bricks are the sheets of graphene embedded with these nanotubes in this manner. So you can think that nanotube is also a very hard material. The sheets of graphenes are also very hard material. So this is a kind of the hardest brick that you can make, right? So, and it's also very light. Why? Because these are not the metal or non-metal oxides, which are in general of much higher molecular weight than this. Now, what are the advantages of this? I'm sorry. The advantage is that first, this is very hard. Then this can be electrically conducting. Okay. This can also be, this also have huge thermal stability. So a lot of things can be thought of, just, if you have, and by the way, what is the thickness of this layer? Single layer graphite, what is the thickness of this single layer graphite? Any idea? What is the thickness of a single layer of graphite? The graphene sheet, what is the thickness of a graphene sheet single layer?
So somewhere in hundreds of picometer, nanometer.
Hundreds of picometer.
I know it's like.
If you can't convince, you confuse, right?
Sir, it is less than 1 nanometer, I think.
It's 2 nanometer. Each sheet.
Less than one nanometer.
Each layer of graphene is 2 nanometer. Okay. So, and the diameter of a carbon nanotube is about 4 to 5 nanometer. Okay. So this is essentially the height of nanotechnology, which can be used for what? This can also be a transparent one. You can increase the layer. It can also become opaque. So you can have a color contrast, right? One can really dope them to make them semiconductors, right? So lots of properties that can be explored around these materials. So as I was telling in the previous slide, that you first have to understand material, then synthesis, then fabrication, then characterization. Immediately you go to the domain of knowledge and applications. Okay. Another example is a very famous problem that is going on. So this is materials and materials. Then synthesis and fabrication. What is the diameter of a DNA, by the way? Any idea? Diameter of a DNA? Somebody is looking for in Google search.
On the scale of nanometers.
How much? How many nanometers?
That I'm not sure.
So again, 2 nanometer. Again, 2 nanometer. Yeah. So that's the beauty of the whole game. If you really remember the numbers, there is a simile. You don't need to remember. So DNA is also the double-stranded helical structure of a DNA. If you take the diameter, that is 2 nanometer, right? So DNA molecules, DNA molecules are essentially nothing but, nanoscale helical structures, right? One of the major challenges of recent nanotechnology is to utilize this DNA and RNA molecules in the form of replacing these gold nanoparticles, because they are toxic, non-biocompatible, whereas DNA and all, they are already inside the system. So question is that, can I replace gold nanoparticle by a DNA nanoparticle or an RNA nanoparticle, which coronavirus is showing the way, is essentially an RNA nanoparticle, right? Which is coming into the body and then, creating havoc. So it is acting in a destructive way, but you can really make use of it in a very constructive manner, right? Similarly, these are applications associated with nanopores. You are creating a pore in such a manner so that only water molecule can escape. So this is a typical problem that is called Aquaporin, where you are just all the sea waters you are accumulating at one place. And then the pore is such that it is able to only produce the water molecule. It just rejects everything. You are designing the pore in such a manner. So it is not only the synthesis of these materials, but also the fabrication of these materials are also very, very important. It is not only the synthesis of these materials, but also the fabrication is important. And after the fabrication, what is important? I need to know whether it is sp2 hybridized carbon or not. I need to know whether it is a DNA or not. I need to know whether this is 20 nanometer or not, or 5 nanometer or not. What is the pore size? So for that, you need the characterization. So material synthesis, fabrication, characterization, if I'm through with all these four, I have adequate knowledge to generate a host of applications, which leads to different types of technologies. Okay. Is that clear? Any question up to this point? So all of you are either scientist or engineer. So those who are scientists, they will be looking forward to develop new materials, say suppose metamaterials, which are the materials that are not understood very well. Some of you will be engineers, how to make use of the material for different types of applications, right? So mantra remains same. You have to really work, you have to know an array of materials, you have to know how to synthesize them. You have to know how to fabricate them. Synthesizing a material only sitting with iron doesn't matter. If I make an utensil of an iron, then only it makes sense. And then you have to go for the characterization, whether it is iron, whether it is chromium, whether it is nickel, manganese. How do I come to know? So the entire technological realm, entire scientific realm is focusing under these directions. We are going to really look into a very small part in terms of computational and in terms of experiments in this particular course, which will appear to be very huge for you. This will appear very huge syllabus, but then this is the basic, this is the fundamentals, this is the foundation that you need in order to really explore all these things. Okay. So if you don't have any question, I close today, and we meet once again on Wednesday at 6. Yeah, Govindo, any question?
Sir, whenever you are saying computational, I'm not getting what does computational stands here, sir.
That means some calculations. Okay, say suppose I want to know whether a material, say suppose you want to coat a thin film, right? Now I want to know what is the force that we apply on the film so that the film breaks. You have made a coating on a surface, right? Before you make the coating, I want to know that, okay, if you are making a coating of, say suppose polystyrene, what will be its strength? How will you come to know? So you need to have a calculation, you need to have a method to calculate, so that you can really evaluate before you really choose the material. You know that whether I'm going to use polymethyl methacrylate, polystyrene, or I'm going to give a graphene coating, what type of coating I'm going to give. Right? You can't do experiments because I have not purchased the material for you. Are you getting my point? So computation means
Yes.
before really getting into the problem, if I can make some calculations and if I can really tell you, right, say what will be the, say suppose you have a pump and you have a pipe which is supplying the sump water into the overhead tank, right? You ask me what should be the diameter of the pipe. I will make a calculation in the beginning, right, to tell you the diameter. If I am an engineer, I will always make a calculation before. So that is what is related to the computation.
Understood.
Correct. Yeah. Any other question? So if not, all the materials will be given to you, to all of you, whatever we have discussed in the class. And then we meet Wednesday to start and get along with the course syllabus. Okay. Thank you. Thank you so much for your attention. Bye for today.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.